Hi roboticist, in the last video we were able to simulate with the controllers a Universal Robot 5 in Gazebo, and we have done it by modifying the official repository of GitHub provided by Universal Robots. And we have done for the robot description, and we have used and we have understood how to adapt the launch file that was provided by Universal Robot for spawning our robot in Gazebo. Okay, so now we are able to send the controls in forward kinematics. So basically, we are using um, if we go here, we are using a joint trajectory controller because we have set it up in this launch file that we have made it together last time. So I'm going to provide the link in the top right corner. Okay, so the most important thing to do now is to start to run and set up the environment for running an inverse kinematics, right? And to do that, what we're going to do is to use and to create a MoveIt configuration package. Okay, so we have already done it, but let's do it with a universal robot without the gripper. Okay, so let's do ROS2 launch MoveIt setup assistant, and then setup assistant launch. Okay, so here we need to create a new model. We browse and we need to pass the URDF chakra file that contains our Universal Robot 5 and our camera. That is going to be the robot model that we have for which we have taken inspiration from the official repository. Okay, so if we go to load files, you can see here that there's going to be our Universal Robot 5 with the camera. So this is a proof that we are creating a MoveIt configuration package from a custom model. Custom because we have put a camera, right? And again, if you want to make MoveIt assistant work, the most important thing is that if you go to the further of this robot model description, the most important thing is that you put a name here, whatever is going to be. I've set up a universal robot. As default, this is going to be pointing to arguments. But if you do that, I remember you that movie setup assistant won't work. Okay, so here let's set up a set collision. Virtual joint, we do not have virtual joints. Then we add a group. Then we can call it Universal Robot 5 Manipulator. Okay. Kinematic solver, we can use this one, KDL Kinematics plugin, and this is using a OM PL planning RRT. Then probably we are gonna do another video to change and to twinkle what is gonna be the kinematic solver, the best kinematic solver for a certain solution. But this uses some random parameters to get the end effector to go into a certain position. Okay. Then now we need to add joints. The joints that we are interesting are, let's say, are 6 joint, shoulder parent joint, and then the other 6 joint. Okay, there we go. So we put the error right, and then here we need to add the link, and the link is going to be from base link to tool 0. Okay, very important, the tool 0. Okay, let's save it. That's all. We are not having a gripper. I will do another video in the upcoming weeks. But basically, that's it. Okay. Now, robot pose, you know already how to do that. This is very easy. Okay, I think that is good. We are expecting here to have something to pick, and then the robot is ready to pick. Okay, so let's save it. There we go. End effector. This time we are not using end effector. Okay. Passive joint. We do not have a passive joint. ROS2 controller. Okay, we leave it as it is. ROS2 controller we need to add, and here we need to use the same name that we have used in our gazebo. And this is very important because otherwise there's gonna be MoveIt that cannot talk with gazebo. And if we go here, we have call it joint trajectory controller. Okay, so this is the name of the controller, and this is the type of the controller. Make sure to do not make some confusion. Okay, so here there's gonna be a controller name joint trajectory controller. Okay, save. MoveIt controller, we need to do the same. Okay. Um, so this is how it's going to be the MoveIt controllers for our universal robots. And then basically perception. Okay, so let's add a point cloud. This is okay because we have a 3D. We have a 3D camera that is publishing on the topic camera. Slash points, okay, and then we need to fill it up. There we go. Launch files, other information, put your information. There we go. Now let's create a folder. This is gonna be inside our source folder of our Qualcomm environment workspace better. Let's call it Universal Robot 5, then camera, then MoveIt config. We are following the convention. Okay, so open, then generate the package. Okay, exit setup. Okay, there we go. So we have created this package. If we go inside, what we're gonna have? We're gonna have the config folder and the launch folder as well. The first things that we need to do is have a look in this URDF. Okay, and so here basically we are loading the universal robot sim, universal camera URDF chakra, and then that we have seen in the last video. But then here we are importing the ROS2 controller that are belonging to this specific package. And if we go here in the ROS2, not here, sorry, in the universal robot ROS2 control.chakra, that is the file that we are including. So basically what we're gonna see that is loading this ROS2 controller, okay? But if we are loading this ROS2 controller, we are gonna see that the plugin that we are about to load is of type more component generic system, okay? So if we do that, we are wasting all the good work that we have done last time. Again, here in this file here that we should load, what we have done? We have done we have created a camera, and then we are using a universal robot macro. If we go to universal robot 5 macro, what we're gonna do is to load this ROS2 control file. So if we go in this ROS2 control tag, what we're gonna do is that we are setting up the simulation gazebo to true. we have did it here. Okay, this is true, so it means that URDF tells to ROS2 that we are using a simulation gazebo. Okay, and since that simulation gazebo is true, then we are going to use this plugin, okay, that is going to be Gazebo ROS2 control gazebo system. Okay, so you can imagine that we need to use this ROS2 control tag rather than this one. Okay, so otherwise we're going to lose all the good work that we have done, and we are not able to spawn the controller in Gazebo. Okay, and this is crucial. So what we're going to do is very easy. Let's comment this out. So let's comment this out, and of course we don't need this. Okay, so by the way, here what I'm gonna do in the MoveIt configuration file, I'm gonna add some YAML file that are very useful for running our kinematics application. Okay, I have done already a video on that. I'm gonna put the link in the top right corner. Okay, so let me copy and paste. Okay, there we go. So we have added chomp planning. I remember you that I have taken this file from the MoveIt resources package from the MoveIt2 repository. Then I have added the learn lerp planning, so probably we can use it afterwards. Then this is the most important thing, the OMPL planning. So here I have set up the Universal Robot 5 manipulator here, and comment this out because it belongs to the Panda robots. Okay, and then I have done Pills Industrial Motion Planner planning, Trajectory planning, and basically that's it. Okay, so we have created our MoveIt configuration package. So before to run, we are not going to use a demo.launch for this package because we are going to spawn directly our robot with our camera in Gazebo that talk directly with MoveIt, and in particular with the motion planning plugin. Okay, so the best things that we need to do is to go first to our simulation package, go to the launch, and then what we're going to do is to create a launch file that spawns a Universal Robot 5 with a camera, but this time we are interacting with MoveIt2. Okay, so then launch.py. Okay, so there we go. What we need to do is to adapt this launch file that works for Gazebo, but we need to add the MoveIt API. Okay, so let's do that. Okay, there we go. So this is the launch file. Don't worry, I'm gonna provide the GitHub repository updated. So basically, if we go very quick on that, okay, so the most different part is this one, okay? And here I wanted to point out the fact that we are using this package, the one that we have just created, and we're gonna load this file that is gonna be in the config, that is gonna be this one, okay? And basically it means that we are loading the file that we have modified in the last video. Okay, so this is the MoveIt config builder function with all the parameters that you need to put. Then we are going to spawn our robots in set up the position in Gazebo. Here we're gonna spawn the robot in Gazebo. We're gonna use RV's config path that we are using here. So meaning that we are running into RV's node. Okay. Then we need to spawn the robot. So we're gonna use the controller manager. Here there's gonna be ROT state publisher, joint state broadcaster power. So meaning that we are loading as an argument this and these controllers that are set up here. Okay, in the config folder of the yam file and in the yam file. Okay. And then here basically we are introducing some delay, and here most important thing, the move group node. Okay, so so if we run this launch file, we should be able to spawn our robot in Gazebo and interacting with MoveIt. Okay, so let's try and have a look on that. Okay, so let's test this launch file. ROS2 launch. Then the name of the package that is going to be Universal Robot 5 YouTube simulation. Then spawn Universal Robot camera, move it. Let's see what's happened. Ah. Ah, cosa c'è qua? Okay, I need to update this one. My bad. So Universal, this is gonna be YouTube sim. Okay, I just made a confusion with the name of the package of this repository. So now it should be good. So let's build the package and test it out again. Okay, there we go. So we have first our robot with our camera. That the fact that is not falling down is a good sign because the controller spawned correctly, at least in Gazebo. Okay, so now what we're gonna have is this universal robot manipulator. This is the planning group that we have set up in the MoveIt setup assistant. Okay, no, so now let's see if it responds correctly. Let's ask to go to the home position. Let's plan and execute, and then you're gonna see that we are sending a command using the MoveIt API, and then the robot responds correctly. Okay, in the real world, or better in Gazebo. Okay, so this is very good. Um, you should notice that is going to be a problem. Well, it's not a problem, but we are missing here the marker orientation, and this is very useful if you want to set up precisely the position and the orientation of your end effector with respect of the environment that you are going to use. Okay, so there's a solution on that, and the point here is that we are not using a kinematic chain. So let's go inside this Universal Robot 5 camera MoveIt. Okay, and in particular, we are loading the Universal Robot SRDF. Let's check this out here. Okay, so the point here is that with this group, okay, we are not setting up a kinematic chain. And as far, honestly, that I have understood, MoveIt makes the interactive marker with the arrows only if you are keeping a kinematic chain. So what we're going to do is to comment this out, okay, and then we are going to use as a group universal manipulator, we are going to use the tag chain. Like this. So we have set up, we are keeping the same name as a group, manipulation group, that is your Universal Robot 5 manipulator, okay? Then we set up a chain from base link to tool 0. And then MoveIt automatically will recognize the end of this chain, that in this case is tool 0, the end point where you need to apply the interactive marker. Okay, so let's close everything and test it again. Build the package. We don't need to source. We just modified. Let's see what's happened. Okay. Guess what? There we go. We have our interactive marker now. So let's check if it's working. Let's ask to go to the home position. Let's go it very fast, the maximum speed. There we go. Okay. Then let's use the interactive marker to go here. Then plan and execute. You see here? So you can feel free to operate and get fun with your interactive marker. Okay, that's all for this tutorial. I hope that you enjoyed. If you like this video and I have given to you added value, consider to subscribe to the channel and hit the notification bell. And if you want to have a deep dive into robotic programming in ROS1 and in ROS2, feel free to check out the masterclass that is still in preparation, for which we're gonna get a discount. All the information are in the link down below. Again, thanks for your attention, and as always, keep learning robotics with ROS.